Okay, I'm going to be going over chapter 3.4, exercise 1, part A, B, and C. And this problem says, rewrite these logical equivalences in Boolean algebra notation. And here are the logical, the, excuse me, the logical expressions, and we're going to have to make them into Boolean algebra notation. Now, in order to understand how we get the equivalences, there's this cool explanation in your notes, 3.4 in the beginning, and you can also look at in the book. There's an explanation on how the different theorems and the logical equivalences and the properties of sets, and also the properties in Boolean algebra, all the commutative and associative and distributive, they all hold the same kind of principles between each of them. So it kind of helps translate the different symbols. And basically, you're gonna, if you can look at a chart of comparisons. What I have here is just the logical and the Boolean without the sets. And so these are the equivalences, and that's how you're gonna make the Boolean algebra notation for each of these logical equivalences. So I'm going to start with part A. And so basically, we're going to start from within the parentheses. So within the parentheses, the P right here is equivalent to A as it shows in this chart. So we'll put A, and then this right here is equivalent to the dot. And then this symbol right here, the negation symbol, is equivalent to the complement symbol. So that is in relation to the Q, and the Q in logical is B in Boolean. So because this is the negation of Q, it's going to be the complement of B. We'll close the parentheses and we're done with that part. Now we'll focus on this is equal to the or here is equal to the plus sign, so there it is, and then P is equal to A, and then the this sign is equal to the equal sign, and there's a P again, so that is A. So that's the answer for part A. And then we're gonna now go over part B. Same thing, where in part B, you see that the negation is outside of the parentheses. So that just means that the parentheses is going to be a complement, as shown in this chart. If you go inside, the P is equal to A. The and is equivalent to dot. So sorry, this is a dot. And the Q is equivalent to B, so this turns into B. And is another and, so that is a dot again. And then we'll go into the parentheses. P is A. The or sign is equal to plus, so that's A plus, and then Q is equivalent to B. So, and if then this is equal to just equal sign, and then it's P again, and P is equal to A. And that is the answer for part B. We'll go to part C. Same as part B, where the negation is outside of the parentheses. So that means the complement sign is going to go here. So that crosses out this. The P is equivalent to A, so we got rid of that. The AND is equivalent to a dot, so as a dot. And the Q is equivalent to a B. And the OR sign is equivalent to plus. And then another parentheses, P is equivalent to A. The OR sign is equivalent to plus sign. Q is equivalent to B. Close the parentheses. This is equal to equal sign. And then T, according to the chart, is equal to 1. And that is the answer. I'll write it nicer. A dot B plus A plus B is equal to 1. And so that is the answer for part C. So basically you want to understand that all the different sets of properties for logical sets and Boolean algebra, they basically follow the same concepts, so that each of the symbols from logical sets and then Boolean algebra, they could be made equivalent, and so you can translate between logical and then sets and Boolean algebra. And that is the end of the explanation for exercise 1, part A, B, and C.